In this video, we'll discuss the argument of a complex number. So let us consider a complex number z as a plus bi. So this number consists out of a real part and an imaginary part. And in a previous video, I showed you how you can plot a complex number on the complex plane. So we have an imaginary axis instead of the y-axis and the real axis instead of the x-axis. So a is the real number and b is the imaginary number. So we can plot a point on the complex plane. Now let us join a line from the origin to that point on the complex plane. Then the argument would be the angle formed between the real axis and that line. So we have noted the argument here as theta, but it can also be noted as the arg of z. And that's the angle formed between the origin and the point on the complex plane. Now it's also important that we will not measure this angle in degrees, but we would rather measure it in radians. So the argument then is restricted between negative pi radians and positive pi radians. So that means I can go in an anti-clockwise direction up until I reach pi, or in a clockwise direction up until I reach negative pi. So that represents a full circle. Let us look at a few examples. In our first example, we have a point in our first quadrant, and we want to find the value of theta in terms of radians. So that's the argument of this complex number. So remember, I can create a triangle, a right-angled triangle. And what the 4 represents is the value adjacent to theta, and the 3 represents the value opposite theta. Now, if I use trigonometry, I know that tan theta is equals to the opposite value divided by the adjacent value. So tan of theta would be equals to 3 over 4. Now, in order to solve for theta, I can use arctan on my calculator. So my calculator, I put arctan, and I use 3 over 4 as my ratio. And that will give me the value of theta, which is 0.644 radians. So remember to set your calculator to radians when we work with complex numbers. Let us look at another example in the second quadrant. So here we have the argument, and we can see that the argument is past 90 degrees. So we find ourselves in the second quadrant. Now we need to use a slightly different way of finding theta. So again, we will use tan, where the opposite value is 2 and the adjacent value is negative 3. So we know that tan theta would be 2 over negative 3. But to find theta, we would say pi, which represents 180 degrees. And we're going to go fully to 180 degrees and subtract this reference angle. So we would need to subtract that angle, which is represented by tan. So we will use arctan, and the ratio that we would use is 2 over 3. Notice we're not concerned with the negative 3, but we will use the absolute values in order to find this reference angle. So if I have pi minus this reference angle, then I'll have the size of theta. So that is equals to pi minus 0.588 and so on. And when I simplify, I have 2.55 radians. Now let us look at a third example in the third quadrant. So in the third quadrant, we will move in a clockwise direction from the real axis. So in the first 2 quadrants, we moved in an anti-clockwise direction. And now to find the argument, we'll move in a clockwise direction. So if I move all the way back to the real axis, I would have moved negative pi radians, or negative 180 degrees. And again, I can use a triangle to find this reference angle. And that triangle, and the length of that triangle would be minus 3 for the adjacent side and minus 5 for the opposite side. But as in the previous video, we'll use absolute values. So in order to find the argument of this complex number, I would consider negative pi, because I moved negative pi all the way back to the real axis. And then I'll add the reference angle. So the reference angle that we will add is arctan, and then we'll use 3 as the adjacent value and negative 5 as the opposite value. So that will be 5 over 3. And remember, we use absolute values. And when I simplify that, I would have the value of the argument of this complex number, which is negative 2.11 radians. So remember to set your calculator to radians when we work with complex numbers. Let us look at one more example. So in this example, we are in the fourth quadrant, and we want to find theta, the argument of the complex number. Now notice that I'm moving in a negative direction, because if you start by the real axis and you move around in an anti-clockwise direction, we're actually moving or measuring the angle in a positive direction. But here I'll have the negative direction because I'm moving in a clockwise direction. So to find the argument, I would again use the tangent in that triangle. So I'll find a reference angle where I have the adjacent side as 3 and the opposite side as negative 1. But remember, for the reference angles, we use absolute values. So theta would be equal to negative, because we move in a negative direction, and the arctan of the opposite, which is 1 over 3. And when I simplify, I have minus 0.322 radians. And that is how we find the argument of a complex number.